Energy management is a term that has a number of meanings, but we are mainly concerned with the one that relates to saving energy in businesses, public sector and government organisations. The energy used by any business varies as inputs change. By determining the internal relationships of energy use, key performance indicators can be clarified that will allow you to establish the following. Whether your current energy use is better or worse than before. Trends in energy consumption that reflect seasonal, weekly and other operating patterns. How much future energy use is likely to vary if you change aspects of your business. Specific areas of wasted energy. Comparisons with other businesses with similar characteristics. This benchmarking process will provide valuable indications of the effectiveness of your operation as well as indications of energy use. How your business reacted to change in the past. How to develop performance targets for energy management program. Then targeted support is used to improve the KPIs through the addition of the following. Identification of saving opportunities through energy surveys or audits involving the physical inspection of plant facilities and process equipment. Employee-focused activities such as campaigns to increase awareness, motivation and involvement in energy management activities throughout the company. Organisational practices such as the formulation of policy, the assignment of energy responsibilities, the provision of training. Facility and process retrofits incorporating more efficient technology. And finally, the implementation of operation and maintenance practices, the energy efficiency impacts. The adoption of Carbon Arc is not a substitute for these actions, but it will complement them. It can often provide useful information when implementing these approaches, thus making them more effective. It also closes the accountability loop by providing feedback on performance improvement measures that have been implemented, even to the point of assessing the return of investment in terms of savings achieved. These benefits include energy cost savings are typically 5 to 15% as a direct consequence of the Carbon Arc program, with reductions in emissions of CO2 and other pollutants. Coordination of energy management policy through targeting of initiatives that achieve maximum benefit and sustaining savings over the long term. Assisting with the acquisition of financing for energy efficient projects through the accurate determination of baseline energy use levels for energy efficient project proposals and the verification of savings. Improve product and service costings by the definition of the energy content of the products and services. Improved budgeting by providing a basis for more accurate projections of future energy use for given levels of activity. By preventive maintenance by increasing the availability of performance data on energy systems. Improved product quality by increasing the level of control on the production process. And finally, waste avoidance by the extension of the principles of Carbon Arc to other environmental management issues such as water consumption, materials management and plant downtime. I have identified through this presentation the basic steps required for good energy management supported by strong analytics. As a rule of thumb, the more data you get, the more detailed it is, the better. One approach to energy data collection is to manually read meters once a week or once a month. However, this data is not nearly as good as the data that comes automatically from smart metering at regular intervals, such as half-hourly metering. Interval energy data contains a lot of information about a building's energy usage, and the Integral Energy Manager makes it easy to turn raw data into useful charts and figures. In the last few years, it's become very common for medium to large sized buildings to have interval metering. Broadly speaking, such metering systems are usually one of two types. In the UK, energy suppliers have to provide their larger customers with half-hourly metering. As well as using the data themselves, suppliers and utilities make data available to customers that request it for energy management purposes. The most common delivery is through a CSV file. A private metering system can be installed by the organisation occupying the building, by either property managers or by a third party that leases the system to the tenants or managers. They usually have multiple meters recording data for separate areas of the building. The more detailed the energy consumption data, the easier it is to routinely identify waste and to track progress at reducing it. Detailed interval energy consumption data makes it possible to see patterns of energy waste that it would be impossible to see otherwise. For example, there's simply no way that a weekly or monthly meter reading can show how much energy you're using at different times of the day or on different days of the week. And seeing these patterns makes it easier to find the routine waste in your building. Patterns of energy usage are often referred to as energy profiles. The charting features of Integral Energy Manager will allow you to create your own energy profiles from interval data for individual buildings and applications. Looking at the energy profiles to find energy waste requires you to have some knowledge in the way the building is operated. The key is to link the energy patterns of energy usage with the operations of the building. Energy profiles show how much energy is being used at particular times of the day or week. You will want to have a pretty good idea of what equipment is using that energy and why it needs to be using that energy at those times in question. If the profiles show energy is being used on times of day when you're not aware of a good reason for the energy to be used, then that's an indication that the energy is possibly being wasted and it's something for you to investigate. To make sense of the energy profiles, you will need to have a good idea of what goes on in your building. Not everything that goes on in a building, just those things that relate to energy consumption. Remember, every building is different, but the following factors are commonly relevant. What is your occupancy pattern? By overlaying security data with consumption data, we can provide a deeper insight into the operation use and the cost of the building. What fuels are used? How is air conditioning controlled? How is heating controlled? The upshot of this is that HVAC energy wastage can usually be identified from patterns of electricity consumption alone. But if you do have interval metering on your gas supply, it's well worth taking a closer look at your patterns of gas consumption too. Are the lights automatically or manually controlled? Most buildings have different sets of lights for different processes. Main offices, meeting rooms, warehouses, security. Your answers to these questions may depend on which set of lights you're talking about. Whilst interval data is perfect for looking at larger patterns or trends, it will not help you calculate how much energy an individual computer or photocopier uses. For those tasks, you'll want to plug in a simple watt meter between the equipment and the wall socket. This could include anything from a printing room to a forklift truck charger. This raises questions. What processes or items of equipment exist that use energy? What sort of energy do they use? When do they use that energy? When do the processes run? When is the equipment switched off? It is important to note that industrial processes can often dwarf other types of energy consumption within the building. If a building has a process of items or equipment that consume a lot of energy, even small changes in the way they operate can often make a big difference in the energy bill. Once energy consumption has been identified and trended, further sophistication can be applied. Our tools employ the use of linear regression to open up the next level of analysis of energy consumption data. But before diving into regression analysis, it rather helps if you understand what a degree day actually is. Degree days are essentially a simplification of historical weather data, outside air temperature data to be specific. Degree day data is easy to get hold of and very easy to work with. Degree days come in any timescale, but they typically come as a weekly or monthly figure. This is useful if you are working with quarterly or annual energy consumption figures. There are two main types of degree days: heating degree days, abbreviated as HDD, and cooling degree days, abbreviated as CDD. Both types can be Celsius based or Fahrenheit based. Heating degree days are used for calculations that relate to heating of buildings. For example, HDD can be used to normalize the energy consumption of buildings with central heating. Heating degree day figures come with a base temperature and provide a measure of how much and for how long the outside temperature was below that base temperature. In the UK, the most readily available heating degree days come with a base temperature of 15.5 degrees C. Cooling degree days are used for calculations relating to cooling of buildings. For example, CDD can be used to normalize the energy consumption of buildings with air conditioning. Cooling degree day figures also come with a base temperature and provide a measure of how much and for how long the outside temperature was above that base temperature. Integral carry out linear regression by correlating energy consumption with degree day data. You might have detailed interval data from a smart meter or monthly records of energy consumption that you've collected yourself, or energy bills from a utility or energy supplier. Most buildings follow a weekly routine, which means that weekly energy consumption data is typically a good option for regression analysis. Although the occupancy of the building and heating patterns might vary throughout the week, the patterns are usually fairly consistent from one week to the next. This data can be represented as further graphical consumption graphs. We have previously explained how to get the two sets of data, that of energy consumption and degree days. In the next step, you will need to correlate these two sets of data. The Integral Energy Manager calculates these automatically through the use of regression analysis for all both regular and irregular monthly consumption patterns, saving the requirement to build complex Excel spreadsheets. Once you have constructed the basic scatter chart, there are a few important extras that you will probably want, which is a trend line, an equation, and an R-squared value. The trend line will follow the straight line criteria to y equals mx plus c, where y equals the kilowatt consumption, x is the CDD or HDD data, m is the slope, c is the y-intercept, r is the correlation, and r squared is the coefficient of determination. Most importantly, if you remember nothing else, the equation enables you to estimate kilowatt hour from degree days. By plugging in known HDD or CDD figures into the equation, you can calculate the predicted energy consumption. You would typically do this to see whether the energy efficiency has got better or worse than it was in the period that you did the original regression analysis for. This will enable you to have determined the baseline interrelationship. While many companies focus on their energy intensity, we hold the view that more detail is provided through this type of analysis, especially the division of total energy to incremental baseloads, where it's essential if consumption is to be managed downward. The final stage to this cluster is the definition of a period of consistent performance that can serve as a baseline or base for a comparison of other periods. For this we include QSUM, which is a powerful technique for developing management information regarding the energy performance of plant or an energy consuming system such as an oven or furnace. For example, it distinguishes between significant events affecting performance, faults or improvements, and finally noise. CUSUM stands for Cumulative Sum of Differences, where the difference refers to differences between actual consumption and the consumption you expect on the basis of some established pattern, what we have called the energy performance model. If the consumption continues to follow the established pattern, the difference between the actual consumption and the established pattern will be small and randomly either positive or negative. The cumulative sum of these differences over time, CUSUM, should stay nearly zero. By carrying out this analysis, you will now be able to provide a choice of the periods of better performance as targets for future performance. However, just finding the opportunities to save energy won't help you to save energy. You'll have to take action to target them. For those energy saving opportunities that require you to motivate the people in your building, our product, Carbon Arc, can make your energy awareness campaign hit home. Essentially, you need to raise awareness of your staff, and for this you need an energy awareness strategy. For a general definition, we would think it reasonable to say that energy awareness is about understanding how much energy do we use, both directly and indirectly. What do we actually use it for? Where does the energy come from? What can we do to reduce our energy consumption and its undesirable knock-on effects? So here's the secret. You don't need your building occupants to gain a holistic awareness of energy consumption. You just need them to understand enough to stop wasting so much energy themselves. And since your mission is to save energy in your building, it's what the occupants do and when they're at work that matters. So recruit a dedicated team of energy marshals from those who share your commitment. It is they who will be able to deliver your message whilst carrying out key functions. These could be to control and monitor the implementation of the energy reduction policy, to monitor the consumption of energy and water waste, to help you identify trends, to set and monitor building performance against realistic SMART targets, to identify, discuss and propose appropriate methods of reducing energy and water consumption, and to raise the levels of awareness with staff, partners and peer groups, to take an active role in identifying areas where energy consumption can be reduced and to implement practical measures for addressing issues and problems. By bringing your definition of energy awareness closer to the building that you want to save energy in, you'll make it easier for people to understand that their actions matter, and they really do have the power to make immediate difference to your building's consumption. Therefore, start now and prepare a definition that's appropriate for your campaign. The more you can relate your facts and figures to the day-to-day actions of your staff, the more likely they will be able to take action. The best results by far will be achieved if you treat your energy awareness campaign as an ongoing process. It doesn't have to be a full-time job, but it will work better if you make it part of your regular routine.